So we'll start this section with a definition, and that's of vector-valued functions. So a vector-valued function is a function whose input is a number and output is a vector. So from Calc 1 and Calc 2, possibly you may have seen functions from R to R. These are functions that take one input and output one output for each input. Now, the difference here is that I'm starting with something in R. So here's the real line. So I'm starting with a point in R, and I'm using this function, let's call it maybe R, and let's call this point maybe t. So some t in R, and I'm taking R of t. R of t is going to be, let's even say in this case, something in 3 dimensions, but of course it could be in a vector in any dimension. But let's say it outputs some vector R of t. Okay, and so of course we can look at one input. It's a function, so we can plug in lots of inputs. Maybe as I collect all of these vectors together, I find that the tips of this vector do something like that, right? It just, through space, is flying around. We've actually already seen some examples of this. We've seen at least one example of this. And so I'll just remind you of lines. Right, lines have vector equations. So we've looked at L of t, or we've called it R of t or L of t. L of t is some vector, let's even just say 1, 2, 3, for example, plus t times 4, 5, 6. And of course, I'm not even going to try to make this to scale. This ends up being some line displaced by the vector 1, 2, 3, parallel to the vector 4, 5, 6. So here's your line, L. And so it turns out that we only need one parameter to define a line. We only need one parameter to define something like this curvy thing. We may need more parameters to define something like a surface. That will come later. But for now, this will be really convenient for defining things that are sort of linear like this.